Hi everyone, in this video tutorial we will analyze gas turbine blade with centrifugal load in Abaqus. We will go through all necessary steps to run our job in static analysis, and we will use titanium material alloy in our material for this simulation. And also we will apply centrifugal load in and rotational body force in our part. Let's get started. We have our gas turbine blade. This is the geometry. We get this shape and this geometry solid parts from STL file of gas turbine blade, and all necessary steps to convert to solid part is used in Abacus tools. We convert to this part, this solid part. All steps presented and we make in previous video how to convert STL file to solid part in Abacus. Now let's go to property module and create our titanium material. Create material, alloy titanium. First we need to select density. In the ton per millimeter cube, the unit of the density, and also we have elastic property of our titanium in the megapascal and percentage ratio. Now we have elastic property of our material model. Click OK. Let's go to create section. Section titanium, solid, homogeneous, continue, select material. OK. And let's assign this section to our part. Click done, select section, click OK. Now we have assigned material to our blade. Let's go to assembly and create instance. Apply. Now let's go to step, create static analysis step, static general, continue, increment. Let's start with 0.1 increment size initial step. Okay, and interaction. We don't need any interaction in this model because we have a single part. We don't have any contact between two parts. Let's go to load, and before we go to load, let's go to part and make partition for this part. Let's first create the tone plan. In this section, select first point from the tone plan, second point, third point. You should select 3 points to create plan. We have this plan in the middle of part. Let's create offset plan. Select the tone plan, enter value, see the direction, the right direction. Okay, let's 2 mm offset. This is our offset. Let's go to make partition using this datum plan. Select cell, use datum plan, select this datum plan, create partition. Now our part we have two cells. The first one the bottom part and the top cell, the bottom cell and the top cell. Now let's go to load and create boundary condition. We have two boundary conditions. The first one is the on-cluster in the bottom cell. Boundary condition, initial step, symmetry on cluster, anti-symmetry on cluster. Select cell, the bottom cell, click done on cluster, click OK. We have the fixed part of our blade. Now let's create angular velocity in the step one, rotational body force, because we have rotation of our wall assembly of the block. Continue. Select the body for the load. Select the wall body, the wall part. Click OK. And now we need to enter the coordinate of rotation, axis of rotation. The first coordinate is 0, 0, 250 millimeter, because the distance between the 0 point and the axis of our block is 250 millimeter. This is the distance of the distance between, or the distance equal to the radius of the circular part of the wall block. This is the distance between the center of our oblique and this point. This is the first point of axis of rotation. Click OK. And the second point, let's add 100 millimeter, for example. And also now we have a wrong value. We have minus 250 millimeter, not 250 millimeter, because we have in the z direction. This is the inverse direction, the minus value, not in the top value. Okay, let's select the second point, 100, and minus 150 millimeter. This is the coordinates, or 2 point from axis of rotation. Click enter. Now we have these 2 points of axis of rotation, 2 point. We have load, centrifuge, uniform, and now we need to add angular velocity equal to 500 radius radian per second. Radian, our unit of angular velocity, is in the radian. Click OK. Now we have all loads applied in our part. Let's go to mesh and create mesh of our part. Select element size. Let's go to part, assign element type, select tetrahedral element. OK. Element size 4 millimeter. Apply OK. Let's mesh our part. Mesh. We have complex shape converted from STL file to a solid in Abaqus. This is make many faces in our model, and also take a time to create mesh. We have meshing of our part. Now let's go to create job, and job 1, blade titanium. In the model blade, select your model, continue. Okay, let's go to Data check first. We have completed job. Let's go to the result and let's see the zone of concentration of stresses, mice stresses, and let's hide unnecessary edges. Apply. Okay. Stresses contours, and let's go to strain, displacement. You can select other data you need to get to this result in this result by going to find output and select which data you need to get in your ODB file. Until now, I hope you enjoy with this video. Don't forget to subscribe in my YouTube channel and like this video. See you